All right, here we go. Homework. These are all the worksheets that you got. Thank you. All the worksheets. All the worksheets. All good. Okay. Hold it down. Hold down. So Luke, Lola, we talked about tests. Mike Crockett, where are you at, Mike? I have your test now. So, are you off any periods?
Yeah, I have 5, 7, 8 off.
I will have your test. It'll be in my other office in the Career Tech Ed building. You know where that building's at?
Yeah.
200 is my office. I have a meeting today from 10:30 till about 1:30 at Grandview, but then I'll be back in the building.
All right.
Cool?
Yeah.
Okay. So, because there's some days I think the test center is being closed and it shouldn't be. All right.
Because the lady's crazy.
Well, I don't know if that's necessarily the problem.
She is crazy. She's crazy.
Okay.
She yelled at me for putting my hand in my pocket.
What? It happens. It happens.
I didn't.
All right. So the quadratic formula. Why? We talked about this a little yesterday. Why am I not the biggest fan of the quadratic formula? Yeah, but the thing is, this is what really frustrates me about the quadratic formula. Not because you guys don't do arithmetic well. It frustrates me when, like, if I'm grading a test and there's a quadratic formula and you did the answer only. You guys know that? And you got the answer wrong, so then I got to mark like 3 points out of 3 points. Versus I don't always see the thought process because a lot of times you make that little silly error. And I truly feel in my heart that completing the square, though it's a little more tedious operation, the nice thing about it, if you get the completing the square down, you'll never make an error with a quadratic formula. Why is that? Because you're not using it. Okay? So, what were some questions you came across on last night's homework that you would like to see worked out? 73? Is that one of the word problems? Okay, what does number 73 say, please? Huh?
I thought we did 75.
66 through 72.
Oh, never mind.
Okay, so not 73. Okay. Any questions you want to go over on these? 96. Is that one of the word problems?
Yeah.
Okay, is there one that's not a word problem you want me to go over?
Oh, never mind. We don't have to do that.
Yeah, it is right here.
No, I got it.
I want to do 96.
Oh, I'm going to do it. I will do it. All right, page 213. Here we go. Let's take a look at this. Page 213, number 96. Okay, for what years were there or will there be 9.7 million self-employed workers in the United States? So they give you this equation. W at x is equal to negative 0.01 x squared plus 0.27 x plus 8.60. Okay, so it says for what years were there or will there be 9.7 million self-employed workers in the United States? So it says the function w at x is equal to that can be used to estimate the number of self-employed workers in the United States in millions, x years after 1980. Okay? So what we're looking for is we're looking to figure out what x is. They gave us y as 9.7 million. So this is our problem. 9.7 is equal to negative 0.01 x squared plus 0.27 x plus 8.60. If you have a calculator, please get it out because I need your help because I can't do this in my head. All right. First thing I'm going to do, let's go ahead and use the quadratic formula. God bless you. I'm going to subtract 9.7 to bring it over. So 0.01x squared plus 0.27x. What is 8.6 minus 9.7, please? Negative 1.1. Thank you. Okay. Let's go ahead and do what they want us. So quadratic formula. And we know that x is equal to negative b plus 9 squared. Okay. So let's figure this out. So we could have multiple years. 0 years counts as 1980. So if we get a negative, it's not that it doesn't exist. That'd just be years less than 1980 if we do happen to get a negative answer. All right, so let's see if we can get this. So I'm going to get x equals negative 2.27 plus or minus square root of 0.27 squared minus 4 times negative 0.01 times c, which is negative 1.1, all divided by 2 times negative 0.01. All right, help me out. If you have your calculator, let's do this. I have negative 0.27 plus or minus. Will somebody tell me what 0.27 squared is? 0.27 squared. All right. Say it one more time, please. 0.0729 plus or minus. Okay. Now. Oh, wait, why did I put plus or minus there? So now let's take a look. I'm going to point this out. I have a negative, and a negative. If I multiply 3 negatives together, what should I get? Negative. So that's out of the way, so that sign's correct now. I need 4 times 0.01 times 1.1. I'm sorry, one more time? 0.044. All over 2 times a. So 2 times negative 0.01. Thank you. All right. So there might be a lot of places we could goof up on this problem. One, we're dealing with decimals, which that's a whole different category. But let's take this a little slower. Let's continue this. Could somebody, using a calculator, go 0.0729 minus 0.044? 0.0 what? 0.0. Is that right? 0.0289? Okay. Could you find me the square root of 0.0289, please? The square root of 0.17. All right. Woo. All right. Let's do the arithmetic. Negative 0.27 added to 0.17 should be negative 0.1. Agreed? So let's go this plus this. And is it negative 0.1 divided by negative 0.02? We'll do this in a moment. And then we'll do the same thing here. This minus, so negative 0.27 minus 0.17. God bless you. Negative 0.27 minus 0.17. Negative 0.44 divided by negative 0.02. So nice thing is both of these have negative answers, so that means that's going to be positive, positive. What is 0.1 divided by 0.02? Just positive 5? Okay. And then what is 0.44 divided by 0.02? How much? 22. All right. God bless you. So let me just make sure we have this correct. It says in 1980 was the start. So in 1980 was our starting point on this problem. So 1980 is where we started. So that means at 1985, and then 22 years after that, and at 2002, your workforce would have been the 9.7 million people. Okay? But there's a lot of places you might have made an error on this problem. Notice I spent my time going through it. I didn't continue to keep things in my head. I wrote it down to make it work. Okay, what else do we have as far as problems go? Yeah. 66. Okay.
See, I told you.
66. Okay. Find all the zeros of the function. That means I want to use, finding the zeros means you're trying to find where it crosses the x-axis or the solutions to the problem. So if I use the quadratic formula, I know that this is the same thing as saying this. To find the zeros, my a value, my b value, and my c value. And this is a classic example of why people goof up the quadratic formula. We're going to start putting more negatives in. There's already a negative in there. And the negative 4 under the radical is also negative. Okay? So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay? So let's plug in what we know. Negative b plus or minus okay. So why would some errors take place up here? We got lots of negatives. A lot of people don't want to, if you plug in and it's already negative, people will forget there's already a negative there. So things that are going to be watch out spots is here's a watch out. So that's just going to give me 3 plus or minus. This right here is that's a huge watch out. Because a lot of people will take negative 3, plug it in their calculator, and square it. And because the calculator gives you an answer of negative 9, you think it's right. What number are you squaring here? The negative 3. So that means you're going negative 3 times negative 3 to give you positive 9. Huge error. I bet you that's the number one spot that the error takes place on the quadratic formula. Okay? You trust your calculator too much. You have a thing that comes through, it makes sense in your mind. Going, okay, I know that, God bless you, I know that negative 3 squared is 9, but my calculator's giving me a different story. And so it confuses you. It goes against you what you know. So trust your brain before you trust your calculator. If you wanted to make that work on your calculator, put the negative 3 in parentheses and then square it, and it gives you the positive 9. Okay? I get it. It's a goof up on the calculator part, but who developed the Texas Instrument calculators? Pretty smart people. Pretty smart people who look at this going, I got it, and they can do it. And that's why the algorithm came out that way. And this happens on almost every calculator. You don't have lower end, people who are, going, making a choice going, should I work, doing this particular job, which is not a high educational job, or should I program calculators? It's two different types of people. So Texas Instruments, HP, Casio, they've all goofed this up. Okay? So please be careful on that. And then I have a negative times a positive times a negative. Negative times a positive times a negative is going to be a positive. 4 times 1 is 4. 4 times 7 is 28. All over 2 times 1. So I get 3 plus or minus the square root, I believe 37 over 2. I'd say leave that. You can't break 37 down any further. Okay? Any others you want to take a look at? All right. Go ahead and just a little humor in the day. I hope that was okay to show you. I have another funny one to show you tomorrow, but I'll get to it tomorrow. So today we're going to talk about graphing the quadratics. Okay? Okay? I'm going to show you two processes that work really well with graphing parabolas. The first one is, let's see, everyone knows a parabola either opens upward or downward, right? Yes, you have the ones that open sideways, but we're not in this class. So if it opens upward, the vertex is happening at the lowest point. If it's opening downward, the vertex is happening at the highest point. Does that make sense so far? Okay. So let's think about how do we get the vertex. Okay, how do we get the vertex? So, and I'm not really going off the notebooks on this, but it's just the way that I see it a little bit better. Okay, something to know about a parabola. If you have this parabola, you have this vertex down here. This vertex is an xy value, which we will eventually refer to hk. So when you start seeing hk in the terms of a parabola, h is the x component of the vertex, the k is the y component of the vertex. Things about a parabola that might not always been taught to you is you have something called an axis of symmetry. Okay, it's an imaginary vertical line which I could take the parabola and fold it over on top of itself, which means that there's a point right here which matches up with a point right here as far as the y component. Okay, there's a point right here that would match up over here. They would fold over the axis of symmetry. Now there's other terminology that takes place with a parabola that sometimes people think it's more important to justify this. So you have the axis of symmetry, which is that purple line. You have something called the focus and the directrix. Now, the only thing I could say when you're going to use this focus is if you're using mirrors in physics. And if you were to have a mirror the shape of this parabola, all light coming in this direction would come through the focus. Okay? Now the directrix down here is just something way different that someone thinks is important someplace. I'm not going to focus on the focus. I'm not going to focus on the directrix. I just wanted you to be exposed that you have terminology you might hear in a later math class, not mine. Okay? So things that I want you to know is the axis of symmetry, which is an imaginary vertical line that goes right through the vertex. You can fold over on top of itself. Okay? But a great way to find the vertex is this. Let's say I knew I had a point here. Let's say I had a point here. So 1, 2, 3, 4, 5. What can you guarantee me right now about the vertex or where it would land about? Middle. So what is the middle number between 1 and 5? 3. So right now, if I were to say this x component is going to generate us or if I found the halfway point between those 2 points, halfway in between in the x direction, that gives us the x component. If I plug that back in, it gives me the y component. Okay? So a way that a lot of people do this is they call it negative b over 2a and then plug in your answer. Okay? And the negative b over 2a comes from when you label it your a, b's, and c's on your quadratic formula. So let's see if we can do this right now. So let's say I had this equation. Y equals 3x squared minus 6x plus 4. So my a value is what? 3. My b value is what? Negative 6. My c value, 4. Do I need my c value right now? What are things that my c value finds? It goes with the quadratic formula. Does anybody know what the c value finds right away? What? Y-intercept, exactly. So things I know about this, if I made this parabola and I started generating it, something right away I would know, and it's not a real vital point, but my c value is right here. Okay? Is that necessarily my vertex? Is that necessarily an important point for this problem? No on both. It just happens to be an extra bonus point if you were to plot a parabola that you know that your constant, your c value, is where it crosses the y-axis every time. Okay? Right now, I don't know if my parabola is to the left of that or to the right of that as far as the vertexes go. But let's go ahead and find it. So using the negative b over 2a, so I know that my a value is equal to 3, my b value is equal to negative 6, and if I were to take negative b, I get negative b over 2a. So what's negative 6? Positive 6. 2 times 3 is 6. So what is the x component of my vertex? 1. Okay, so the x component of my vertex is going to be 1. That's my x value. If I take that x value and plug it into the other x values, I will get the function of x, or the function at x, which in this case will be y. Okay? Walking through this problem, 3 times 1 squared minus 6 times 1 plus 4. Order of operations would say do the square first. So 1 squared is 1 times 3, 3 minus 6 plus 4. So I get negative 3 minus 6 is negative 3 plus 4 is, so at 1 comma 1, I'm going to get my vertex. Okay? Now this is going to be a little interesting problem here. Will it cross the x-axis? No. Will it cross the y-axis? We found that. What's the lowest point this parabola has right now? 1, 1. Which direction does this parabola open? Upwards. How do we know it opens upwards? The squared term is positive. Okay? Now, I will know that if I go right 1, up 3, I get to this point. If I go left 1 and up 3, I get a second point. So I can pattern graph off of these. If I wanted to find another point, I would go from my vertex, I could go right 2 and up 6, or left 2 and up 6 from my vertex. Okay? But right now we can say that we've just established 3 exact points. This happened to be a coincidence that it pattern graphed to that point. Okay? Did this cross the x-axis? What would happen if we used the quadratic formula on this problem? What would happen if I used this on this problem? What do you think? Why is there no solution? It doesn't cross the x-axis. So what would happen if I used the quadratic formula on this problem? It would equal something, but what would happen? X would equal 0? Not quite. There you go. Say it one more time, please. Good. So, if I use the quadratic formula on this problem, this portion right here, once I did the arithmetic, would have been negative. Okay? Would have been negative. That's not too bad, is it? So, deeper meaning to this is, if we find our vertex, that's either the highest point or the lowest point, if our a value, which is attached to our x squared, is a positive number. The parabola opens upward. If it's negative, it opens downward. By using the same letters, the A, B's, and C's, I can go ahead and start figuring out the vertex, because negative b over 2a finds you the x component of the vertex. The y component, you just plug that x value back in that you found, and it'll give you the y component. And then you can pattern graph. And so when we pattern graph, some teachers, and I don't know why, but some teachers feel, give me 5 defined points. I think 3 is good. Is the vertex a point? So would that be a defined point? Heck yeah. And then from your vertex, if you went right one up A, left one from the vertex up A, that would find you a second point on the other side. Is that 3 points? And if you're able to plot your y-axis, your C value, 0, C, you might actually have a 4th point that you define. So a little critical thinking on these works nicely. Does anyone know where this type of math would take place outside of this classroom? Where? Could be architecture. Each and every one of you were a product of this type of math this morning as you got to school. Driving. The braking distance. Any type of object which has a braking distance is a quadratic formula. Okay? Now, can you push your brakes harder sometimes and softer other times? Yeah. But what if you ran a test knowing you're going to push with 100 pounds of pressure on that pedal every time? Would that be an okay test? So you're going to drive the vehicle, and then you're going to immediately put 100 pounds of pressure on that brake pedal. If you did that continuously, you're going to get a quadratic equation where the left side of it is not going to make sense, the right side will take place. Now, I'm not telling you that because I expect you guys to go out in the parking lot and say, okay, if I'm doing 5 miles an hour, 100 pounds of pressure, put it on my wheel, look, 6.2 feet to stop it. I'm not asking you to do that. But do you think that car companies or tire companies or brake companies do this? So if any of you ever, let me ask you this, if you don't want to admit to it, we'll go this way. How many of you know somebody who drives a minivan? Okay? Now you don't have to identify your parents, they're the minivan driving folks, God bless them if they are. When they first came out with the minivan, the whole idea was this. Let's get rid of the station wagon, because the station wagon was kind of, it was kind of fading out. So they brought a minivan in, and a minivan is this. They took a car frame and put a taller structure on it. And then they started finding that there was a lot of minivans that were getting into collisions. The reason they started getting into collisions is they were using the same size brake pads that the car had as a lighter object. Now you have a heavier object that you're trying to stop on the same size brake pads that you stop the smaller car on that same frame. So when the whole minivan revolution took place, there was a lot of people that were getting in accidents in minivans. They were saying, oh, they're so unsafe. Well, they're so unsafe because the car company didn't account for the size of the brake rotor it should be. Now it's appropriately done, and they're stopping a little bit better. So things that I want you to try and work on tonight with this assignment, I think you'll be able to do it pretty well. Let's go here. Let's go with page 226, 8, 25 through 29. And this is just graphing parabolas, okay?